So anyway, yesterday we talked about 3.2 complex numbers. We talked about I being an imaginary number. And we had initially kind of mentioned that I exists for the problems that we have when we had square roots with negatives inside the radicals. If we had a negative inside a radical, it created a no solution question. Now we are making it so that we are allowed to answer any question that will have a square root or a negative inside of a square root. I stands for the square root of -1. This is a big, as I mentioned yesterday, this is a very big SAT section. So if you're looking for SAT review and prep, this is probably the best section that you can look for, okay? The hint that the SAT is always going to give you, they're actually going to put it in parentheses and they're going to say the word hint. They're going to say I squared equals -1. That is all they will give you for these types of questions. But you should know at this point, if I take the square root of each number, I'll get the square root of -1, right? So this is what they're going to give you. That means the exact same thing. It doesn't change what you're dealing with. This is going to be something that's going to be really, really important though. Okay, so this is going to be extremely important for you later on. You need to remember that I squared is -1 because when we deal with that, it's going to be important. Okay. We had also broken down something that looked like this. I said that we wanted to simplify the square root. I think yesterday we used 32. Today we're using the square root of 96. Very simple to break this down because all you have to do is break it into two radicals. And it's just like the normal radicals that we break down, right? We find two numbers that multiply to give the number in the inside. -1 and +96 give me -96. Then I go through and I just write as simplified versions of things as I can. So maybe this one breaks down into the square root of 16 and the square root of 6, right? The square root of 16 is 4. The square root of 6 doesn't simplify. All right? So that being said, I circle the things that I'm using. And then I just rewrite them. The form that you guys will see all the time is this. So when you see this written in a certain form, you're going to see 4 times I times the square root of 6. If you rewrite this in any other form, like this, if you write any of those forms, they're technically correct, but this is the one that the SAT is going to use. This is the one that I'm going to use, and this is the one your book is going to use. So always put the whole parts together and then put the radical by itself on the outside. Okay, that's just a 2-minute version of what we did yesterday. Did someone just have a question?
Are we supposed to put the plus and minus in front of it?
So that's a really good question because plus and minus is one thing that people always get stuck with. And this is just a little hint. So you use the plus or minus when you introduce the radical. So if I ask you a question that says something like x squared equals -96, you would then solve this by doing the square root of each of these numbers. You have introduced the radical here, which means that your answer would be x equals plus or minus, and then we just solved this. It was 4i times the square root of 6. If the question said to simplify, exactly like the last question said, where it was to simplify the square root of -96, your answer would just be 4i times the square root of 6. You only introduce the plus or minus when you put the radical in there. In this question, the radical was given to you. In this question, you put the radical into that answer. So if you introduce the radical, you have to have the plus or minus. If it introduces the radical, no need for plus or minus. Very good question. Does anyone else have any questions on anything so far? Okay, so the next thing that we need to talk about is complex numbers. That was just the introduction of I. Now what we're going to do is we're actually going to introduce complex numbers. Now complex numbers I don't know if I'm losing my mind, but I'm pretty sure I just did that and it didn't change the color. So complex numbers are always written in a standard form. Oops. Complex numbers have to be written in a standard form, and that standard form is a plus b times I. Okay? This has two parts to it. It has a real part, and it has an imaginary part. So it has a real part and it has an imaginary part. A and B are both numbers that you're used to dealing with. So an example of a complex form, standard form thing after you get simplified would be something like 5 plus 3i. If I have something that looks like 5 plus 3i, my real part is 5 because 5 is a real number. My imaginary part would be 3i because I is an imaginary number. So this is what your answers will look like if you are simplifying something from standard form, okay? All this is a big disguise of combining like terms. All this entire thing is combining like terms. That's all you have to do here. So all you have to do is combine your like terms. So for instance, if I give you a question that says to simplify or to write the complex number in standard form, and I just give you a whole bunch of stuff like 3 plus 3i minus 2i plus 1 minus 3i squared, so on. If I give you something that looks like this, you are going to combine your like terms. But the first thing you need to do is you need to recognize, that was weird. You need to recognize I squared. Because we just said that I squared is the same thing as -1. So that means that this value right here, once we start to simplify things, is -1. So when I rewrite this entire equation, I have to know that I squared is not imaginary. I squared is -1. So that I is going to go away completely. So when I rewrite this, it will look like 3 plus 3i minus 2i plus 1 minus 3 times -1. This is now completely just combining like terms. You can even think of these I value things as x's. So you can think of it as an x term and just combine them like normal. So what I'm going to do is I'm going to underline my real parts, and I'm going to underline the imaginary parts in a different color, and I'm just going to combine those things. Okay? So this will simplify down to 3 plus 1 is 4, and then -3 times -1 is +3. So 3 plus 1 plus 3 is 7. And then 3 minus 2i is just 1i, so I would put plus I. So that's how complex form, complex numbers simplify and break down. Okay? Any questions that you guys can think about with that? Beautiful. So the next thing to think about is you could have a question that says something like solve for x and y given something like this, 5x plus yi equals 35 minus 20i. You could have something that looks like this. Now, if you have something that looks like this, most people are going to freak out because they see that they have an x and a y. And if you have an x and a y, this is a really good SAT question, by the way. So most people freak out on this because they see that SAT style stuff and they think, okay, well, I'm going to have 2 different equations. Or if I have 2 different equations, I'm going to have to try to figure out another equation. If I have 2 variables, I have to do something to those variables to try to get them to be able to be solved. But if you think about this, we just said a second ago, we just said that this was the real component because it doesn't have an I attached to it. And this is also a real component because it doesn't have an I attached to it. We then said that this is the imaginary component because it has an I attached, and this is the imaginary component because it has an I attached. So all I have to do is set the real part equal to the real part, and I have to set the imaginary part equal to the imaginary part, and then I can just solve. So here, obviously, we could solve for x, and x would be 7. If x equals 7, this would be 35, and 35 is equal to 35. If I look here, obviously, this part and this part have to be the same. Oops, that was bad. Those 2 parts have to be the same, and if they're the same as each other, that means that y has to be -20. So when you plug those numbers back in, your equation would say 35 minus 20i equals 35 minus 20i, which is a true statement. So this is a very simple process if you understand the process. Very, very confusing if you don't understand the process. Okay? Does anyone have any questions about those things? Okay, the very last thing that I want to talk about, and then I'll be all done, are operations with these numbers. Operations just mean multiply, add, subtract, divide. Okay? And mostly it's going to be multiplying, adding, and subtracting. Okay? What you need to think about is your answers always need to be simplified into complex form. So your answers should always be a plus bi or a minus bi at the very end. All of your answers should look like that. Your job is, if you're given something that looks like this, your job is basically to just combine like terms. So what I'm going to do is look through and find what terms are the same. The biggest mistake that people make, so if you're into like making notes and putting stars next to things, the biggest mistake that people make is for some reason they look at this and they try to multiply them. They just make this thing negative and then they try to multiply them together. This is a subtraction symbol. This means that you subtract those two things, okay? So what I like to do is rewrite them, distributing the negative. So I do 13 plus 4i minus 8 minus 2i. I've distributed that negative to both things in here. But I like to make that extra step because then I for sure am not going to multiply them together when they don't need to be multiplied together, okay? So now I'm going to look at my real parts, real, imaginary, imaginary, and I'm going to combine them. 13 minus 8 is 5. 4 minus 2 is positive 2i. And that question would be done. Okay? It is literally as simple as combining like terms. If you replace the I with an X, this is something that you probably did freshman year. The only thing that makes this more challenging is if I ask you to multiply. Adding and subtracting is a piece of cake. It's just adding and subtracting the same way that you always have. Multiplying makes it a little bit tougher. So if I have something like 2 plus 3i and then 3 plus 4i. The only thing that you have to pay attention to, because this is a double distribute problem, we're going to take this times this, and this times this, and then these two, we're going to do this, okay? Now that being said, the only thing that you're going to have to pay attention to that's going to be different than normal FOILing is the I squared is equal to -1. So if you notice, when I start this problem, I'm actually going to treat it exactly like this said 3x and exactly like this said 4x. So I'm going to do 2 times 3, which is 6. 2 times 4i, which is going to be 8i, 3 times 3i, which is going to be 9i, and then 3i times 4i, which is going to be 12i squared. So it's the exact same thing as normal terms, normal stuff. Now that being said, I just have to pay attention to this. If I squared is equal to -1, that means this thing right here is equal to -1. So my real equation should be simplified as 6 plus 17i plus 12 times -1. I can now see that this is a real part and this is a real part, which would mean that I have 6 minus 12, which is -6 plus 17i. And that would be simplified down to that, okay? Does anyone have any questions? That's all I want to go through with you today. I know that that was kind of a sped up process and I didn't really give you a lot of time to practice any in class, but I don't want to sit here and make you watch a screen for 25, 30 minutes by giving you time to answer questions. I'm going to give you that time to answer questions and ask questions now. Okay. So if you have any questions, don't hesitate to let me know. Don't hesitate to ask. Don't hesitate to go forward and say like, hey, I didn't understand when you did this or this. All you have to do is combine real parts with real parts and imaginary parts with imaginary parts. This is the first half of section 3.2. We're going to go more into applications with it tomorrow, but I want you to get a feel for what you're seeing now. Okay. So does anyone have any questions about this right at this moment? All right, I'm going to stop my